Welcome to Brain Vision.
Our question says, show that the following combination of three fundamental constants of nature that we used in example 10 of introduction, measurements, estimating, that is G, which is the gravitational constant, C, which is the speed of light, and H, which is Planck's constant, forms a quantity with the dimensions of time. Therefore, T sub P is equal to the square root G over H divided by C to the fifth. This quantity, T sub P, is called the Planck's time and is thought to be the earliest time after the creation of the universe, at which the current known laws of physics can be applied. So I wrote here what we were given. I used brackets to represent the dimensions of the quantity. So if I put a bracket around the quantity, what I'm writing is the dimensions of that quantity. So the dimensions of capital G, which is a gravitational constant, is dimensions of length to the third divided by mass, which is capital M, times time squared. The dimensions of H are mass times length squared divided by time. And the dimensions of the speed of light, C, are length divided by time. So then the question says, show that T sub P has dimensions of time. Okay, so let's go ahead and do that. Let's find the dimensions of T sub P. So write the bracket because we're finding dimensions of T sub P. Well, let's write what T sub P is equal to. Oh, that's not a very good square root symbol. Let's write what it's equal to in terms of its dimensions. So the first one is G, which has dimensions of length cubed divided by mass, mass times time squared. Okay. And then the dimensions of H, or Planck's constant, are mass times length squared, let's extend over our square root, divided by time. That's the numerator. And then in the denominator, and the square root actually extends all the way down to the denominator. So let's go ahead and do that. And for good notation here, let's erase that line. Okay, so then in the denominator, we'll write the dimensions of C to the fifth. So C has length divided by time, and all of this is to the fifth. Okay, well, let's go ahead and simplify this now. Well, the masses are going to cancel. The mass dimensions cancel. That's nice and easy. Length to the third times length to the second gives us length to the fifth. Then T squared times T gives us T to the third. Okay, and then all of that is divided by length over time to the fifth. So you have length to the fifth divided by time to the fifth. And then this whole thing is under the square root. Okay, so this can be rewritten again where the lengths cancel out, right? They're both to the fifth. Now you're going to have the square root of T to the fifth divided by T to the third. Okay, and that's equal to the square root of T squared, which is T. So therefore, we've just shown that the dimensions of T sub P are indeed time.